Chemistry videos, how to do unit conversion. Now this is one of the things that we're working on right now in Unit 6. We've been working on it all semester long, but this is a good review, and then from this video you would want to go in and watch the how to do a basic stoichiometry problem. Alright, first of all let's review the rules. If you follow these exact steps you shouldn't have any problem. Step 1 is we draw a T or the fence. Okay? Number 2, we place the number and the unit in the first top box. Okay? Number 3, we would place the unit from this first number into the bottom of the second box. Step 4, we place the unit you want to go to in the top of the second box. Step 5, we find the number of this unit and place it also in that second box. And then number 6, we do our cross-canceling of similar units and we do the math. Remember, anything that's on top of the fence line, we multiply. Anything that's on bottom, okay, top and bottom, we would divide, okay? Now, I know this is confusing. Let's practice. So here's a simple little problem. How many molecules are in 50 grams of water? So as I said, first thing we want to do here is we want to draw our fence. So I'm going to start and draw my fence line and put my first post in, okay? Now, it says how many molecules are in 50 grams of water. So I know I want to go to molecules. I've been given 50 grams of water. So, as it said before, I take the number and the unit and put in the top box. Now I'm going to add my second fence post here. Now the second thing I need to do is it says I take the unit of this first number and I want to put it in the bottom of the second box. Okay? Now I want to go to and put in this top box the units I want to go to. Now remember, what we need to do is we go from grams to moles, okay, to molecules when we actually have to figure out how many molecules. So I have to go from grams to moles first. So the first thing I'm going to do is I'm going to put this unit up here on top. Now I have to figure out what's the number that goes to this. So I take a look and I figure, okay, 1 mole of water equals how many grams? And if I add up my 2 hydrogens and my 1 oxygen, I figure out that it weighs 18 grams. Okay? So now I can cross-cancel already. I see that's above and below. I can cross-cancel. Put in our next fence post here. I want to immediately take this unit, put in the bottom of the next box like it said in the rules, and on the top of the next box here I want to put in molecules. Now we know that there are 6.02 times 10 to the 23rd molecules in every mole. Okay, so then once again I can do my cross-canceling here. I've now gotten grams, rid of grams. I've got moles. I've gotten rid of moles. I am now at molecules, which is where I want to be. So I can put that down here in my final box. And when I do the math, as it says, multiply across the top. So that would be 50 times 1 times 6.0 times 10 to the 23rd. And then I would put that number here. Then I would take and go along the bottom and do multiplication down here. Nothing here, so I got 18 times 1 is 18, okay? And then I would divide this. Take this number and divide by this number. And when I do that, I should come up with, let me get a different color here so it shows up, 1.67 times 10 to the, what did I get on my calculator? 24th. Molecules, and we're working on water. Now that's a very basic, okay, put our fence line down, put our posts in, and as it says, put the unit you were given, we were given grams, we put it on the top, and we put it on the bottom of the second one. I need to go to moles, I put it on the top, I put it at the bottom of the next one. And then I want to end at molecules, it should be in the top of my very last box, whatever unit I need to go to. Then put the numbers in that correspond. Let's try a different problem. Or before we get to that problem, let's take a look at what we want to do here, because as I just said, we need to remember this. If I'm going to go from grams, okay, to moles, or moles to grams, I can go either way there, okay? But what I'm going to look for here is the molar mass of the reactants. And how do I find that molar mass of the reactants? I go to the periodic table, okay? And I add that up. Now, from moles to moles, this is what we're working on in stoichiometry now. We use the mole ratio. And we worked on this in class with the ChemQuest and the POGIL about mole ratio from looking at the balanced chemical equation. That'll take me from moles of reactants to moles of products, or from moles of products to moles of reactants. I can use it either way. Once again then, if we're going to go from moles to grams, okay, we need the molar mass. And how do we find a molar mass? We've been doing this all year. We look at the periodic table. These things down here are going to be part of this chart, but we're not going to use those right now. We will look at those later when we get into gases, the existing recording. Okay, as we can see here, if I want to go from moles to grams, or grams to moles, okay, here, I have to go one step to the other. So here's another problem. How many grams, it's a unit we've been given, of calcium carbonate are there in 2.5 moles? Okay, so this is where they want me to go. This is what I've been given. I put my fence line down. I put my first post in. I take in my first box, I write down the unit, moles, and I put it in my second box, moles. I take the number that they've given me, 2.5, I put it up here, and I got to figure out then grams. This is where I want to go. And just from looking at my past chart here, add the existing here and get past this. All right, so I got 2.5 moles of calcium carbonate. Calcium, 2 plus charge. Carbonate is one of my polyatomic ions. 2 minus charge, that equals calcium carbonate. I know that calcium weighs 40 grams. I know that carbon weighs 12 grams. And I know that this is 16 times 3. My oxygen. And if I add all that up, I know that there's 100 grams in 1 mole of calcium carbonate. Now, I'm at the unit that I want to be at, grams, so I'm done. Now I do my math. First, I cross-cancel all like units above and below my number line. Then I do my math. 2.5 times 100 would be 1, 2, 3. So I'm going to go 1, 2, 3, 2,500. Okay? And then divide it by 1. So if I have 100 grams and I got 2.5 moles, I got 250 grams of calcium carbonate. And I hope that was a little bit clear. Jumping back and forth might have caused some problems there. Okay? Here's one that we're going to work on basic stoichiometry. So remember, when we're working on stoichiometry, first thing we have to do is create a balanced chemical equation. So we're going to look at this. How many grams, that's what they want me to go to, of water can be made from 30 grams of oxygen and an excess amount of hydrogen. So it says I've got hydrogen gas, and we know from Brinkelhoff that's an H2, plus oxygen gas, that's in Brinkelhoff, O2, is going to create water. Okay? So there's my chemical equation. Now I got to balance it. 2 hydrogens, 2 hydrogens. Okay there. 2 oxygens here, 1 oxygen. I got to add a big 2. Now that changed my hydrogens. Now I got 4 hydrogens. I got to come over here and back big 2. So now I've got 4 hydrogens, 2 oxygens. 4 hydrogens, 2 oxygens. I'm balanced. So here's my, basic chemical equation that I can start to use with. Now they want to know how many grams of water. How many grams of water here can be made from 30 grams of oxygen gas. So if we put our picket line in here and start off at the bat like it talked about, first thing I do is write down what I was given, grams, okay, and 30 of them. I got to go to grams of water. They gave me something on this side, and I got to get this side, and I got to get to this side. So I know when I go from one side of this to the other, that has to be mole to mole. So I got to turn grams to moles here. So I go grams here, and I take the same unit and I put down here, grams. Now I'm going to end up figuring out, okay, what do I have here? I got 30 grams of oxygen. So I need to go to moles. I put that unit up here, okay? Now, in 1 mole of oxygen, I look at that and I see oxygen weighs 16. There's 2 of them, so that would be 32 grams. Okay, so there's my first one. Now in my next box, I go now from moles of oxygen to moles of water. So I've got to go to water, put that in here. It's my unit. Oxygen's down here. It's the unit that I just came from, okay, because this is 1 mole of O2 here. 30 grams of O2. Let's put that in here so everybody can stay straight. Now, what is my ratio up here? Talk to me about in my balanced chemical equation. This says 2 moles of hydrogen plus 1 mole of oxygen gas will make 2 moles of water. So my ratio here is 2 moles of water for every 1 mole of oxygen gas. Okay, and those are in moles. So right off the bat, now I can see I've just gotten rid of oxygens. I've gotten rid of grams of oxygen and moles of oxygen. I'm now into water. So right now I have water left over here. Okay? So if I was to do my math already, I would say 30 times 1 is 30, times 2 is 60. So we'll just write that up here, 60, and that's water. And down here I got 32 times 1 is 32, water. So right off the bat, if I do my math here, 60 divided by 32, let me get my calculator out. 60 divided by 32 equals 1.875 moles, because I'm still in the mole area of water. Now it wants to know grams, so I need another picket fence here. And I have to look at, I need to go to grams, so I put grams on top. I take the unit that I am at, put on the bottom, and when we add up water, we see that this is going to equal 18 grams per mole. 2 hydrogens plus 1 oxygen gives me 18 grams per mole. So I take this and I can cancel moles and moles, and when we take 1.875 and multiply that by 18, it comes up to 33.75 moles, grams, because that's my unit I have left, grams of water. Okay, and that would be my answer. I would end up boxing that over. So we'll take a quick review. Put on top of my number line, okay, unit that was given. And I immediately take and put my unit that was given over here, okay, on the second box. So in the top of my second box is unit I'm going to. Okay, so that way units given, units given. Now if I only have to take one step, which I remember from my chart, then I would be done here. But if not, then I would take this unit and put down here and put my new unit up here. And I just keep repeating this process on and on and on until I get to where I want to go. All right? I want you to review this as many times as possible so you got it down. And then once you get done with this, I want you to find the other one that says how to solve a basic stoichiometry problem and practice this. If you have any questions, make sure you write them down and bring them in. And remember, chem is try, never, never, never give up.